Good afternoon, my students. Today the topic number 15 of our lesson, application of definite integrals. Definite integrals have many applications. We can use the definite integrals to find the area of region bounded a curve, the volume greeted by rotating a curve, the length of curve, the mean value of function, the center of mass of an object, and projective problems. Consider the question finding the area under a curve. Other applications: calculating the volume of solid of revolution, finding the length of a curve, calculating the area of a surface of revolution. Finding the area under a curve, finding area, let function from a to b, real numbers, be continuous functions such that for every x positive functions, then the area of the region between the function and axis on the interval from a to b is integral from a to b functions dx. The area between functions y is f of x, the y-axis, and the lines y is m and y is n. Capital A is from integrals from m to n, f of y dy. We can use the formula for the r and the curve that defines the area between two curves. Let f of x and g of x be two curves. Then the area A between f of x and g of x on the interval from a to b is capital A is integral from a to b f of x minus g of x dx. For example, find the area A of the region bounded by the graph y is x plus 1, the axis, and the lines x is 2, x is 4. You see the solution of definite integral. Answer E is 8. For example, number 2, find the area of the finite region between the graphs y x squared plus 1 and y is 5. Before we begin, we need to find the interval for the integration. If you sketch a round graph, we can see that the interval is set by the intersection of the two lines y is x squared plus 1, y is 5. Therefore, my need to solve the two function simultaneously to find the upper and lower limits for the integral. Then we can find the finite integral between two limits, from minus 1 to 2. You see the solution of the integral. Answer 34/3. Other applications: calculating the volume of a solid of revolution, finding volume, let function be continuous function defined on from a to b, then the volume of the solid generated by rotating the area between the graph of function and axis on from a to b about the axis is volume p integral from a to b f squared dx. For example, what is the volume of the solid figure generated by rotating the area between y is 3x and axis around the axis on the interval from A to B? Look at the figure. Using the theorem, we can write volume is 24 24p. Calculating the volume of a solid revolution. If you rotated a figure around the y-axis, then the volume is greeted by x is f of y, and we integrate if it with respect to dy. P integral from c to d f squared y dy. Find the volume of the solid figure generated by rotating the region function 3x minus 1, the y-axis, and lines y is 2, y is 5 around the y-axis. To find the volume, we find x in terms of y and integrate the expression with respect to the y. We see the solution of the integral, answer 7p. If you rotated the area between two curves f of x and g of x on the interval from A to B, then the volume of the solid figure generated is p integral from A to B f squared of x minus g squared of x dx. Look at the picture. For example, find the volume of the solid figure which is generated by rotating the area of the region bounded by the graph 2x squared plus 2 and 3 minus 2x squared around the axis. Intersection point plus minus 1 over 2. The solution of the definite integral, answer 10p over 3. Finding the length of a curve. Find the length of the graph a function 4x minus 2 to the power 3 over 2 between x1 is 1, x is 2. Using the formula we get with the solution of the definite integral. Calculating the area of surface of revolution. If function has a continuous first derivative from A to B, then the area A of the surface generated by revolving the curve about the axis A is 2p integral from A to B f of x square root plus 1 f derivative squared dx. Such a surface is called a surface of revolution. For example, find the surface area shaped with radius r is 3. Let us take the circle x squared plus y squared is 9. Note, let us use the between x is 0 and x is 3 and rotated it. This will give us half of the surface area with the shift, so we need to multiply the result by 2 to obtain the whole surface area. You see the solution of the integral, answer 36. Lesson is over. Goodbye.